Hello everyone. So, libp2p is a modular peer-to-peer networking stack which provides different pieces of functionality to be able to build all different kinds of peer-to-peer networks. So for example, if you want to build a local-only peer-to-peer network, you can just use the MDNS module for discovery, and you don't need to use a DHT and so on and so forth. So it gives you a lot of flexibility. So this is a really high-level overview, and it's going to rush through a lot of things and skip a lot of detail because it's a big stack, but we'll see how we go. A libp2p node, it consists of a switch, which has a connection manager and a connection muxer, and a libp2p host, which is a protocol muxer that then feeds into the protocol handlers. One of the biggest projects using libp2p at the moment is IPFS, which is a distributed peer-to-peer networking file system. Yeah. So this here is a very simplified view of like what the IPFS node looks like from the libp2p perspective. So we have the identity, ping, bitswap, DHT, and pub/sub protocol handlers, and they feed into the different systems that make up IPFS. So this is a quick example of how we connect two peers together in IPFS using the DHT. Part of it uses the DHT, which is just finding it in the first place. So we pass in the peer ID, which is a hash of its public key, and then we get back any addresses that that peer has announced to the DHT. We then use that plus the peer ID to connect directly to it. So we have an established connection. Now, once we have that established connection, we can then move on to actually using the protocols and communicating between the two nodes in whichever way we choose. This looks very different for any other kind of libp2p application or node set, but this is the start for what IPFS does. So what about the cloud, or Kubernetes in particular? I'm going to quickly go over what this string means. This is a multi-adder, or a multi-address. It's a self-describing format for addresses. It has some excellent properties, such as you always know what protocols you're using. So, for example, you'll see there that TCP is mentioned in front of the port number. So, obviously, then if it's a UDP, if it's listening via UDP, that would also then be changed to UDP. So you can always figure these things out from the actual value itself. There's no contextual knowledge that you need. But when you add these concepts of peer identity, so as I mentioned, important with the establishing secure connections in peer-to-peer networks, with public to private network traversal and load balancing with multi-addresses, we hit some difficulties. So peer-to-peer networks in general, but libp2p in particular, reduces the importance of the location of a service, so in particular the IP address. Instead, it places a lot of importance on the identity of a peer. So when we attempt to make a connection, we need the peer ID to match the one we intended, and the IP address, it can change, it's fine. So in the case of a connection request that gets round-robined between some replicas, for that connection to be successful, we have to land on the pod that has the peer ID we specified. If we don't, the connection is going to get refused. So what is the solution? I don't know. I come from a peer-to-peer world, so I don't have the solution at this point in time, but I would love for anyone who has any ideas or has an interest in this to come and talk to me, reach out. I should mention Protocol Labs is hiring, and we would love for you to come and help us solve these problems. So yeah, thank you.